Hey guys, in today's video, we're going to be using all the knowledge that we've learned so far in Chapter 3 and in Chapter 4 to talk about how we graph lines using slope-intercept form. So in 4.4, we learned that the slope formula, so our slope m, was y2 minus y1 over x2 minus x1. So in other words, our change in y over our change in x, which we can also refer to as rise over run. So if we're given a graph and we're asked to find the slope, all we have to do is pick 2 points that fall relatively nicely on the graph. So for instance, I noticed that this point here lies nicely on our graph, and this point here also does. And when I say nicely, I mean that it lies on a point in our grid line. So it lies right here in our grids. So to find our rise, all we have to do is see what our change in y is. So if we were to go all the way down to our point, what is the distance there? Well, our distance would be, starting at our point, 1, 2, 3, 4. So we know our rise is 4. To find our run, all we have to do is look at the difference in our x values. So from here to here. Well, this would be, starting at our point, 1, 2. So our run would be 2. So our slope is rise over run, which is 4 over 2. So our slope is 2. There we go. And then in 4.3, we learned how to find intercepts. So remember, the y-intercept is just where our line crosses the y-axis. So remember, our vertical line is the y-axis, and our line, the blue line, crosses the y-axis right here at the point 0, 4. Since we had to go 1, 2, 3, 4 places up. So our y-intercept would be 4. So that would be how you find the slope and the y-intercept given a graph. So let's talk about slope-intercept form. So slope-intercept form is in the form y equals mx plus b. And what this does is it gives us an equation of a line that tells us m, our slope, and b, our y-intercept. So again, m stands for our slope, and b stands for our y-intercept. And that's why we call it slope-intercept form, because our m is our slope, our b is our intercept. And our y and x we just leave as y and x since we're looking for an equation of a linear line. So if we want to find the slope and y-intercept from the equation, all we have to do is look at what's in the m place and the b place for our equation. So remember, slope-intercept form is y equals mx plus b. So in this case, whatever's in front of the x is going to be our slope. So 2 is in front of our x, so our slope would be 2. And then our constant, the number that's being added or subtracted, is going to be our b. So we have -1, so our y-intercept, or the b value, would be -1. So slope equals 2, y-intercept equals -1. Go ahead and pause and see if you can do the next couple on your own. So for the next one, we have y equals -x plus 2. Now it's important to remember that when we have a negative in front of an x, that implies that we actually have a -1 in front of our x. So to find our slope, our m value, we just look at whatever's in front of the x. So in this case, we have a -1 in front of our x, so our slope is -1. And then our y-intercept is whatever our constant is that's being added. So in this case, it would be +2. So our b value equals 2. So our slope, again, would be -1, and our y-intercept would be 2. Make sure you pause and try to do the next one on your own. So we're given y is equal to 7x plus 4 all over 2. So this one's a little bit different. It's not necessarily in slope-intercept form yet, since we have everything over 2. But what we can do is, since we only have a single term in the denominator, but 2 terms in the numerator, we can actually separate the right side of our equation into 2 separate fractions. So we can rewrite this as y equals 7x over 2 plus 4 over 2. So I just wrote this into 2 separate fractions, both being over 2. And we can simplify this a little bit just because 4 over 2 is just 2. So we have y is 7x over 2 plus 2. So now this is in the version that we're used to. It's in our slope-intercept form. So all we have to do to find our m is to look at the number in front of x. The number in front of x is technically 7 over 2. So our slope will be 7 halves. And our y-intercept will be our constant that's being added, so plus 2. Let's look at some different examples. So now we're asked to graph the equation. So let's draw our coordinate plane to start. Now, when we're graphing linear lines in slope-intercept form, our step 1 is to start with the y-intercept. Our y-intercept, our b, remember, is our constant, so -1. So our y-intercept is -1 right here. Now, we can use our slope to graph other points to create a line. So our slope, remember, if there's a negative x, that implies that we have a -1 here. So our slope is -1. But -1 is technically -1 over 1. So our rise is -1 and our run is 1. That tells me we're going to start at our intercept. We're going to go a rise of 1. But since our slope is negative, that means we're going to go to the left 1. So this point here. So again, our slope is negative. So that means that our line has to be in a downward trend. Remember, this means you're walking along and you're going downward. So that's how I knew to go up 1 and to the left. And there's our line. So in other words, our second step is to use our slope to plot another point. Why don't you try to do letter B on your own, and then we'll come back and do it together. So we got our coordinate plane. Start there. Now remember, step 1 is to start with our y-intercept. Our y-intercept is 2. So we'll start at the y-intercept of 2. Now we'll use our slope to plot another point. So our slope is 3, which again is technically 3 over 1. So our rise is 3 and our run is 1. Also, our slope is positive, so that means we want to have an upward trend. So our line will be positive. So we have a rise of 1, 2, 3, and a run of 1. So to the right 1. Here's our second point. And then we'll make our line. And there we go. All right, let's try another one. This one's a little bit different. We have y is equal to 7. So it might not seem at first that this is in slope-intercept form, but it actually is, and I'll tell you why. So 7, since it doesn't have an x next to it, that means it's our constant. So that means it's our b value. So our y-intercept is 7. But since we don't have an x term, that tells me that our slope would have been 0. So our m would be 0. So let me show you how it looks if we were to write this out again. So we'd have y is equal to mx plus b, our slope-intercept form. But our b value is 7 and our slope is 0. So we have y is, m is 0, so we'll plug in 0 for m, times x plus 7. But remember, 0 times anything is just 0. So we have y is 0 plus 7, or in other words, y is 7. So that's how we got this equation. So if we were to graph this, we start with our y-intercept, as always. So up 1, 2, 3, 4, 5, 6, 7. But then our slope is 0. And if you remember back to 4.4, a 0 slope is just a horizontal line. So that means we would have a horizontal line that goes through 7 on the y-axis. So there's our line. For D, It's actually not quite in slope-intercept form. To be in slope-intercept form, we need to have y on its own. So we have to manipulate our equation just a little bit to make sure that y is on its own on the left side of the equation. So we have to get rid of this 3x. Well, the 3x is being added to y right now, so we have to do inverse operations. The opposite of adding 3x would be subtracting 3x. So we'll subtract 3x from both sides. So we have y is 1 minus 3x. So remember, our slope is whatever is in front of our x. And in this case, even though it's kind of in a different order, we have negative 3 in front of our x. So our slope is negative 3, and our y-intercept is going to be our constant. So right here we have a 1, which implies that it's positive since it doesn't have a negative in front of it. So our b value would be 1. So let's graph it. We start with our y-intercept. We have b is equal to 1, so our y-intercept is 1, and our slope is negative 3. And remember, this is negative 3 over 1, so that means we have a rise of negative 3. So we'll go up, 1, 2, 3, and then we want our graph to be negative since our slope is negative. So that means we'll go to the left 1. So our next point would be here. And then we can just connect these two. And there's our line. Alright, so how do we know if two lines are parallel? Well, if we were to look at a graph of two lines that are parallel. Let's see, we have this line, the pink line, and the blue line. Now, if you look at these two lines, what you might notice is that they never touch. And that's what parallel means. And that's because their slopes are the same. So in example A through C, we have to figure out if these two lines are parallel or not. So let's check it out. When we're talking about if two lines are parallel, we have to look at their slopes. So let's call this equation 1 and this equation 2. So the slope of equation 1, remember that's whatever's in front of our x value. And since there's nothing there, that implies that we actually have a 1. So our slope is 1. And the slope of our equation 2, again, there's nothing in front of our x, so that implies there's a 1 there. So their slopes are the same, so that means that they are parallel. Try to do question B on your own. Answer if these two lines are parallel or not. So again, we have equation 1 and equation 2. So the slope of equation 1, that's whatever's in front of our x, and in this case, it's negative 3. For equation 2, we have positive 3 in front of our x, so our slope is positive 3. Now, positive 3 does not equal negative 3, so our lines are not parallel. For example C, I had to add another equation in there because I forgot to put a second one, so we couldn't answer the question if they're parallel or not. The first equation is not quite in slope-intercept form yet, since y isn't on its own. So we have to solve for y first. Right now, y is being multiplied by 2, so we have to do inverse operations. The opposite of multiplying by 2 would be dividing by 2. So we'll divide everything by 2. So we have y is... Now, again, since we have one term in the denominator and two terms in the numerator, we can rewrite this fraction as two separate fractions. So we can rewrite this as negative 2x over 2 minus 4 over 2. And that simplifies just a little bit more. Negative 2 over 2 is just negative 1. So we get negative 1x. And then 4 over 2 is just 2. So minus 2. So now we can compare these two equations. We'll call this equation 1 and this equation 2. So we have y is equal to negative x minus 2. So remember the slope is whatever's in front of our x value, which is a negative 1. So our slope of equation 1 would be negative 1. Our slope of equation 2, since there's nothing in front of our x, that implies a 1. So our slope is 1. But 1 does not equal negative 1, so our lines are not parallel. Alright guys, that's it for chapter 4. We're going to be moving on to chapter 5 next, which is kind of an extension of what we learned today with graphing lines.